Hi guys, welcome to Quantum Voice. This is Pratyusha Chilagani and this is Yogesh Matreja. Yogesh, why don't you explain what Quantum Voice is?
Quantum Voice is a set of videos and podcasts centered around AI and modern technology. In this series, we are going to cover how AI is impacting various fields out there, from dating to music to lifestyle to linguistics. And we are going to talk about the history of those fields, how AI is impacted it currently, and what the future holds for us moving ahead. Right?
Yeah.
So, Pratisha, who are you?
My background is in electrical engineering, actually. Education in electrical engineering, masters from USC in electrical engineering. And I worked for Intel for about 3.5 years and quit my job. And I returned back to India and took my time, and I started learning neural networks off of Andrew Ng's lectures. Also, during this time, I kind of invested in a couple of high-tech startups, and the interest in this field kind of eventually got me here.
Lovely.
Yeah. What about you?
So, for me, I started learning computer science and coding when I was 11 years old, and I developed my first program, first software at 13. After that, life had other plans for me. I kind of studied fashion and then business, and started a few companies, failed in a few, started a tech agency as well. And throughout the love for computer science was always there, but this Quantum Voice is my attempt to rekindle myself back with my passions. And so this is about Quantum Voice and us. Let's start with the video.
Hi guys, welcome to Quantum Voice. In today's episode, we'll be looking into linguistics and artificial intelligence. We'll be looking into how the language evolved. We'll be discussing about linguistic computation and how linguistics and language and cognition are interlinked, how the brain works, especially when it comes to language learning. We will be looking into NLP, NLU, and where the future is leading in the space of AI with respect to NLP and NLU.
Wonderful. So where do you want to get started?
So why don't we start with the basics? We can look at the evolution of language. How do you think we humans have come up to the point of speaking a language?
See, overall, there is no hard science which can track down how language evolved. Okay, so we have to rely a lot on anthropology and paleontology, these branch of sciences to understand about evolution of language. But more so, even hardcore linguistics are just taking guesses, theorizing. So most of the paleontologists believed that language evolved with the evolution of Homo sapiens, that was around 30,000 years ago. But if a recent theory by Professor David Everett, he's a professor of linguistics in Bentley University, if his theory is to be believed, he says that language came into existence with Homo erectus. So according to his theory, Homo erectus used to sail from Indonesia to Africa, or like Africa to Indonesia, and the sailing was majorly for transports, goods, a lot of business activities. So if that is to be believed, especially the sailing as an activity cannot be done without a sort of communication in place.
Right.
Though communication is not much dependent on language per se, but when it comes to communication for complex activities like this, sailing for example, we need few symbols. Okay, few symbols, few rules, basically a language to communicate with people. So he says, with Homo erectus, around 350,000 years ago, a language, though not so complex like ours, was in place. And overall, I think the language we have right now is result of our evolution, right? Along these lines, from Homo sapiens to Neanderthals from Homo erectus to Neanderthals to Homo sapiens, we have evolved a lot, right? At a time, on average, human population was not more than 1 million for like a few millennia at a stretch, right? Even till around 15th century, on an average, human population was around 3 million or so.
Right.
But with growing population, with industrialization, and now with the evolution of tech and everything, the language has evolved into a very complex subject. And it is just not about communicating anymore, right? We transfer our knowledge, whatever we know, whatever we think. So language has been developed as a process, as a baseline to form the thoughts to communicate to someone, right? Either in form of writing, either in form of talking, either in any forms, right? So it has become very complex. And if I go back, I believe that David Everett's theory is right. As per anthropologists, as per people who study human evolution, right? All the traits we have right now has been a result of this evolutionary process, right? So I think the need is developed in a generation, and another generation gets the tool, and another generation evolves that tool, and so on and so forth. Yeah. So if I theorize it this way, I think David Everett might be right, because as per my understanding, invention of fire was the first ever activity where we felt the need to communicate the knowledge, right? The fire was like, when we discovered fire, we knew, like, the person who invented it, he knew how to start a fire. But going forward, if he has to tell it to somebody else, right, he needs some symbols, he needs some ways, right? So that's where the need arose. And why not? Because fire was the first basic scientific tool that humans got, right? That helped us through dark nights, through cold, and
through hunting.
Yeah. So fire was one tool where we as a human civilization, we started evolving much faster
Because of fire.
Right. So that's where we felt the need, and see where we are right now. Right.
Before that, I think the communication was pretty how do you say, minimal, meager, or maybe it was so understood between groups of communities among how they divided their activities. I think mostly people communicated through gestures before fire, you think? Not with words or not with sounds, or
it was with Homo species. It was mostly either with sounds and gestures, right? Like, the life was not very complex before, right? There were like very few basic activities which as a species Homos used to do, right? They were either like hunting, food gathering, or child rearing, or like these were very basic activities, and they never needed any communication per se.
Right.
So it was like right now, even if you see animals, all the mammals have a basic sense of communication within them. If you see dogs howl, bark, to communicate
they have
certain
a single stimulus.
Yes. So this is how they communicate, right? They don't need language, right? Or maybe there is another doubt of mine that maybe they have a language which humans can't understand. But how we look at the language is certain set of symbols, certain set of rules, grammars, right? So and then the certain set of symbols form words, sentences, and so on.
Right.
Right? So this is how we look at the language, right? But with other species, it can be very different as well. But with humans, it is properly defined, and now we have more than thousands and lakhs of languages spoken all around the world, and also the language has been seen as something which develops human brain more faster in the evolutionary process.
Right.
So though I think the language was the result of human intelligence, which is what we have right now, but also language play a huge role in cognitive intelligence as well.
Right. So do you think there is a lot of ability in us as human beings, which we think, we reason, etc., but language does not play any role, in the sense that there are probably words, but you can those words cannot kind of map to the abilities we have, certain abilities we have. In which ways language is limited is what I'm trying to say.
So language has its own limitation as well, right? There are quite a few research done on the basis that humans can't understand quite a few things if they don't have a word or a phrase to describe that phenomenon. The process, I think it is called hypocognition.
Okay.
It's like when you don't know a feeling, you feel strange, but you don't feel what you can feel. Okay. I'll take an example of the term benevolent sexism.
Benevolent sexism. Okay.
Yeah. So now, when this term, right? So you don't know how to feel. But when I will tell you what benevolent sexism is,
so I begin to feel what exactly.
So benevolent sexism is like when men are very kind enough to compliment in a way where they are actually being sexist.
It's working.
Yeah. So now when you know a certain term, that exists, a certain phenomenon that exists. Now you can process that information. And if you come across something happening on the same lines, you will react to it, right? But when you don't know about it, it's very difficult to react. So that's where the limitation of language comes in.
Right.
And a lot of fiction, science fiction talk about languages in a very, very strange ways.
Yeah. And one more thing, do you think that the languages from another species or from another planet, they have evolved cognitively differently, and if we get to understand their language, will we be able to evolve? For example, we watched this movie Arrival, and what are your thoughts on evolving cognitively differently because of a certain language that we are learning?
I think that plays a huge role, especially in the movie Arrival. Though it's a fiction and it is stretched heavily, but I think it makes perfect sense when the protagonist understands the language of the aliens.
Right.
And then she can understand the time, and there she has the entire move of time figured out. Like she can see through what was in the past, what is in the future, and understand the entire things. So I think that's how that's the power of language, right? And why not just close home if we see there has been quite a few research done on multilingualists or people polyglots have more cognitive power, have more cognitive intelligence than the people who can speak just one or two languages. And during even the tech boom in India, BPO boom, which started around 90s, there was quite a few researches done why Indians are smarter in terms of computers and computer sciences and related fields. It turned out it was because most of us know more than two languages, right? So there is one language, Hindi. It is the most common language spoken in India, right? So now almost all of us, 70-80% of the population knows Hindi really well, right? And English has been taught to us from school, from childhood, because English is the global language and we need to learn that, right? So these two languages are by default. And then third is our mother language, which you for example has Telugu, I have Sindhi. So all majority of the population can speak more than two languages here, and which makes according to research, which makes Indians more smarter than other like people from other countries.
So basically, we are a little more cognitive and understanding, have an understanding of things at many other dimensions than, say, somebody who is limited to speaking one language. I think that's where even Arrival comes, right? Like where she's able to understand her dimension of understanding has kind of expanded, or she even probably leaped to the dimension of time to understand how it is, which we are not there yet.
Hopefully soon. Hopefully not.
I would like to understand that.
But anyways, so in the entire process, we are talking about language and cognition a lot, and we are talking about cognitive intelligence, right? What exactly is cognitive intelligence, and what role does it play along with language?
So cognition very simply is the ability to understand and the ability to reason. And in the process, we we set goals, we become creative, and we try to solve problems. So basically, reasoning aspect and understanding aspect are basically defining cognition. Now, how language and cognition are interlinked, it is very funny. For a child that is growing, language actually, the learning part of language actually comes very easy, as opposed to learning a skill, maybe, say swimming or painting or any of these things. Apparently there is a story or even a real case where a kid was really unable to even tie his shoelace or something like that, but he landed up learning 16 languages or something like that. Okay. So I think the language learning mostly comes with a certain effortlessness, whereas other set of learning which comes under general purpose cognition, which involves learning skills like painting, even seeing, listening, hearing, and writing, and all these things come under general purpose cognition. But special purpose cognition is where the learning language part comes, which is very different from these. Now, in the beginning, there were these theories of called behaviorist theory, where learning or cognition sort of developed only through stimulus, in the sense that there is something happening, we get a stimulus, and through repetition and practice, we learn until it becomes a habit. That was a very old theory, sort of.
But I don't think this is how language works, right?
Exactly. This is not how language works. For example, a child that is of 3 years or 4 years of age and has come to understand the mother tongue, fairly well, can actually correct a foreigner who is speaking the child's language. Somehow she has the ability to understand the grammar without even maybe even looking at all the rules or the syntax of the grammar properly by that age.
Yeah, I think Noam Chomsky says that we are born with language as a part of our DNA, right?
Yeah, what he says is we are all equipped with something called language acquisition device. Now, this part of cognition, this part of faculty in the brain is very separate from other learning faculties in the brain, and that they are not interlinked. And he has kind of defied this behaviorist theory, saying that you and I look at a painting, your response to it is different. You might say, oh, the painting is large. I might say the painting is very old, or our stimulus is different. So the behaviorist sense of learning doesn't apply to language learning. He says that we are equipped with this language acquisition device where we do have the grammar ingrained. Now, what exactly happens here is, while we are beginning to learn a language though, it all starts with the interaction. For a child, it starts with the interaction with their mother, father, or trying to communicate about the surroundings about her, and that is a stimulus, but which goes into the language acquisition device. And there the beginning of language learning happens, and the output is, of course, language. And the funny thing is that we all form sentences that we have not heard before.
Oh. But how does it play a role in cognitive intelligence?
I think, like you said, different language learning abilities will give to different cognitive abilities as well.
Interesting.
Yeah.
So, but is it isn't it vice versa that human intelligence is the one which gave the birth to language, right? Also, at the same time, when we look at creativity part of cognition, most of the creative process that we do is from painting to cooking to music creation. A lot of these activities don't require language per se, until unless and especially all the processes which we can do individually on our own without involvement of another person. I don't think there is a requirement of language in all those processes.
Yeah, I agree with you. Actually, it's while we are saying that we are equipped with language, we are also saying that we do not need language for other kinds of learning. But here, just the cognition itself is separate for both in our brain, at least physiologically. It's not proven, or we do not know that yet. But the ability of learning other kinds of learning does not involve the cognition that is actually required for language. Now, over time, I do agree with you in the sense that we have evolved to build language. Even though Noam says that we are equipped with this language acquisition device, even that is part of evolution.
Yeah.
Right? I mean, we were born with nothing. We actually came out of Wales, all the sea,
we evolved from sea.
We walked from sea, exactly.
Yes.
So we are not born with the language acquisition device, to begin with. It also came as an evolution. But apparently the kind of faculties for learning a lot of things that we learn are not entirely directly tied to the language faculty, is what is...
So, is this why language or linguistics is playing a huge role in AI as well? We want to train AI system language first and then everything else. Why is NLP or NLP or linguistics is a huge part of AI?
Yeah, I think no, not I think. Actually, AI, literally the foundation of AI is to club both these kinds of learning, the general purpose learning and the language learning. Now, what comes with language is an understanding of our universe. What are the parameters of our universe? Why do people act the way they act? We have a sense of going forward, going backward, and hypothesizing based on our knowledge of the world and things like that. Now, other general purpose learning which doesn't involve language are literally action based. We started off AI literally looking at action-based things which are very computational in nature, which is basically, maybe even mechanical in nature, having a robot pick up thing, put there, no language is involved. Maybe we have a robot to even paint, no language involved. Or any of these activities which are not language, but the ultimate target of reaching AGI is to combine language and the general purpose learning abilities within AI. That seems to be the foundation on which AI is built, and that's why NLP is so important to have it equipped with AI.
Interesting. So what exactly is NLP?
NLP is natural language processing, plainly put.
That I know, but yeah, what exactly it is?
So it is basically coming up with a system which understands human language, takes input, understands the instruction, and executes the instruction as expected. So that seems to be the crux of it. But I think we are right now we are still struggling with understanding the syntax of language. Understanding the sentiment. We've come much far, literally in the past 2 years, with the improvement in a lot of the algorithms from the base algorithms. But still we have not gone so far as to expecting a system to kind of take our instructions and execute them.
Right. So we learn language a little bit morphologically, right? So we understand, from syntax to semantics to words to their sounds, everything, right? Mnemonics. Does machine understand the language in the same way?
No, not as holistically as we understand. I think the machine functions differently as opposed to how we function when we hear a reading comprehension. When we read something, we comprehend differently. But when we have a machine read, it comprehends in a very limited.
So how does machine comprehend? So we usually do we read, process the information at the go. Maybe skip if we think that it is not worth reading something, and we'll skip a line or two. And there is an entire gamut of processing when it comes to human.
Yeah, right? We are spoiled with choice.
And so, how does machine process this?
I think basically machines are computational in nature. They understand only zeros and ones, right? I mean, you have anything to add on here? So
basically, that is machine language, right? So only the thing they can do is make decisions one after another, right?
Exactly.
So everything is input is taken. It takes an input, checks for one thing. If it is yes, then move ahead. If it is no, then goes on and so forth, right? So it converts everything into this binary code of zeros and one based on what program we are feeding it into. Right? Yeah. So I think this is how NLP also works.
Yeah, absolutely, no different.
But what are the I think I'll be taking a quantum jump over here by asking you this. What are the models or how this process is evolving throughout.
Yeah, I think to begin with, it's as you said, machines only understand in terms of like numbers, and words are not the same as they are for machines as they are for us, right? So the words have to be kind of translated to a machine understandable language. I think in the beginning we had what we call our recursive neural networks, which were they used to take sentences in a very sequential format. For example, Yogesh, I am bored. Okay, now I have to feed every word in that order, but by the time it comes to I am bored, it forgets Yogesh and
Everybody forgets Yogesh, but yeah.
Anyway. There was this problem with attention retention. I mean, there wasn't, and it was computationally extremely expensive, and you can only feed few words, not even like a few sentences. So people used to do what is called bag of words. For example, I have to understand, I will read an IMDb review, and I want a machine to I want to understand if it is a good review or a bad review. So basically I want the machine to read a bunch of reviews and just give me a binary response of good or bad. So now with recursive neural networks, we just feed a bunch of words from what could attribute to a positive review. It was good acting, good characterization, good cinematography, etc. All these words, good, excellent, all these are bagged together to map to a final output of good. And all the negative responses of maybe boring or not good direction or whatever, these are bagged together to give a negative response. These were the basic crude applications to begin with. And then they try to fix the attention retention problem here by going to what is called LSTM. It is long short-term memory.
Okay.
Yeah. Again, here what they did was they tried to have some words from a previous input, skip the current processing, so that the processing so that the retention is increased there. But again, here the same problem that we have to feed everything sequentially. Now the thing is, the current GPUs do have the ability to take sort of parallel input. So we are not using the high computational power by just feeding things sequentially. So that changed again when we went to transformers, where there was basic encoding and decoding.
Are you talking about the movie or Transformer as a model? I think you're talking about the model Transformer.
Yeah, it's a bad joke. Okay. So yeah, I think so very crudely putting it, these transformers were the first huge leap into being able to take a bunch of sentences, bunch of words parallelly, and we were able to actually translate a text from English to say French. So that was a huge leap. So
Google Translate was based on Transformer.
Yes, yeah. It was based on that, and this was again improved to what we call BERT, which is the current model that is being used very expansively. And this particular model actually helps in not just language translation, but text summarization and sentiment understanding and that sort of thing. And here, I mean, the most interesting thing about BERT is that when I speak to you and I say a sentence, a word in the sentence has its context with its relation to other words in the sentence.
Mm.
So a word is not just a word anymore. It is being given relation to other words.
Mm.
So in BERT there are like just two main important mechanisms that are happening. One is called masked language modeling. So what exactly is happening is, like, if I have to train you to understand context, basically the best thing I can do is give you a sentence with some blanks, and if you have an understanding of context within you, you will fill the blanks.
Interesting. So I think this is how humans also make sense of things, like once they understand language well enough, right? So we don't delve much into mnemonics, or we don't delve much into meanings of the words, because that is an automatic process. We don't delve much into syntax also, especially while speaking, right? Writing is another ballgame altogether, right? But especially when we are talking, we don't delve into syntax also, like grammar, right? But we delve a lot on semantics, right? So when let's say you say that you are heading home, like I don't jump from what does you mean here, what does I mean here, what does heading means here, what does home means here, but yeah, so heading home is my keyword, and I just understand you are going home, and that is all right by me. Right? Yeah. So that's how my brain functions, process the language. And I think this is the same way BERT is doing it.
Yeah, you are able to give weight to heading home because you have the context, understanding of context here. So basically, even in BERT, it's the same thing. We are first making it able to understand context by giving a bunch of sentences and asking it to fill in the blanks.
Wow.
So it will read all the words that are not masked, and it will fill in the masked words. So to train it though, you will actually feed in a bunch of data. So basically you supervise the training, saying that, like, for example, if I have to teach you what fill in the blanks have to be filled, if I have to teach you context, I have to give you a text for you to understand, get an understanding of the context. Now later, if I give you something else, because of your understanding, you can fill in the blanks. I've already supervised the learning to you. So it's the same thing that we are doing here. We supervise the learning of understanding the context and then doing it. And then another most interesting thing is there is a sentence 1 and there is a sentence 2. Now overall context understanding happens if I know sentence 2 is the right sentence to follow sentence 1. Right. I mean, I'm able to speak to you, and somewhere you know that the next sentence that I'm speaking really
relates to the previous one.
Relates to the previous one, which helps you build the whole context again.
Exactly, yeah.
Again, this is supervised, where you feed in a bunch of sentences, and it has a lot of embedding, context embedding, word embedding that is going on, which learns from existing work by Google, which is done like bunch of heavy BERT networks, which have like 320 million parameters.
320
parameters.
Okay.
So it already has that, and now if I want a specific application of either text summarization or sentiment analysis or whatever, I actually take all that 320 parameters with me and then just train the last few layers based on the specific application that I want to tailor my model to. So that's where we are at with the application, etc.
So now I think when we are talking about language processing, right? But we have evolved from not just processing the natural language technically. We are also understanding the language, right? So earlier it was just text input and voice output, or text input and text output, where machine just needs to understand text only.
Right.
And text is easily understandable because they are nothing but the strings, and all the values can be associated with it. So understanding a text based input is rather much more easier. But now we have evolved from natural language processing to natural language understanding as well. Right. So, what models are used when it comes to, say, for Alexa or Siri or any of these devices when they understand this language, natural language understanding, and NLU it is called, right? So, what are the models in NLUs?
I think if we're talking about Alexa and Siri, there is definitely a translation from voice frequencies to words, and then again from those words going into these algorithms. This is what I believe, where there is the sound input being converted into text. That is, I do not know the specifics about the exact streamline of this thing, but like, you have any idea about how this goes about?
So far, see, basically, if I have understood this enough, when I am speaking to you, right, what is happening is there are some sounds made by my vocal processors, right? These sound travels through waves and falls on your eardrum, and your brain picks up those signals and processes it and understand what the other person is saying.
Right.
This is how the process works. And I think this is the same way how it works with the machines as well. Only thing they need to learn extra apart from the language is the waveform of the language. Right? So what Alexa and Siri or any voice assistant does is they take up the wave signals, convert these wave signals to the possibilities of words. Right, and with all the continuous learning, continuous repeated learning, it has evolved to a level where they can understand words in different accent as well.
Oh,
right?
Okay.
So this, I think Siri right now can understand more than 30 accents, right?
Of the same language,
of
of
the
English.
same English, and now right now Google, can understand not just English, it can understand, Google Voice Assistant can understand Hindi and other regional languages from India and a lot of languages from around the world. And more than that, Google Voice Assistant can differentiate the dialects as well. Now, dialects and language are two different ballgames altogether when it comes to understanding. So, when you tell these voice assistants, they translate your voice and takes it into a signal format. So where they have set of statements, set of keywords inbuilt, and they will take those keywords and translate it into commands, and then process the output, right? So that's where the limitation lies right now. So if you say Alexa to play a song or to buy something for you, it can do effectively well. Or say turn on the light, turn off the light. So these are basic commands which it can take right now. And same way, Google Voice Assistant will search something on Google for you, or Siri will respond. So if you ask Siri, tell me a joke, it will come up with a joke and tell you. Or if you say, call Pratyusha, it will search for your number in my phone book and call you. But these are still limited to, certain input and output functions. It is not beyond that. Right now, we are not at a level where technology can effectively talk to us.
Right.
So if we share something, it can respond. If we have a dialogue with us. Though there are quite a few chatbots apart from these which are being worked on, where a day-to-day exchange can happen. So as we'll be talking about these chatbots in dating, so there are quite a few virtual dating apps where people can date a virtual persona. Right. So what they do is, you have a day-to-day interaction with them.
Right.
So if you say, I'm feeling sad, or, my day was shitty, they can come up with certain things which can reaffirm my mentality at that time.
Oh, okay.
Yeah. So
they ask a question or something like
NLU
that.
has evolved to a level where they can just not understand what you mean, they can also respond to
Appropriately.
you appropriately, in a way where it fits and right with you. Right. So
yeah, I think I think this is again understanding of context, right?
This is like very
it's eerie and
eerie. Yeah,
it's very scary. No, I mean, I don't want to go. Already, I think we keep getting messages and suggestions based on our set activities, and they are.
So yeah, as I was saying, so language understanding, or NLU, is not limited to just understanding what we are saying anymore. The entire process has been advanced. AI has been advanced to a level where it can write lyrics on its own. It can write books on its own, stories on its own, and also, like, there are a couple of movies already up on YouTube which of which the screenplay was written using AI tools.
Yeah.
Right. So, but again, like, what do you think where the future is leading to?
All that you have said it is leading to that. Nothing is cohesive, though. I think I know the movie that they've made off of the screenplay that was written by AI. It is very interesting in the sense if you watch it, then you will know how actually AI is thinking or tailoring, like, a bunch of screenplays that it's reading and putting dialogues together. Pretty incoherent, but still interesting to see how cohesive it is.
Yeah.
So I think the reason for it not being that cohesive is that it is still, just very text intensive.
True.
And
but do you think it can replace human functioning in especially these domains entirely?
We are not very far from it. I mean, or I would say, like, we are far from it, but it is not impossible. We'll get there eventually. But also, I think right now the mainstream application is really with BERT and the context understanding, sentiment understanding, which is still not full blown, because these systems do not understand our world as a whole.
Yeah.
I think, like we were talking about, how if we read something, we do understand what the world within that text is. These algorithms do not understand the world of what we are giving it. I think the research has not progressed to that stage. I think somebody from MIT was suggesting that our goals, we shouldn't lose sight of our goals.
Yeah.
I think the next set of goals should be where we make the machine have an understanding of a faithful world. The interesting word is faithful here, I think, because it has to be cohesive, meaning it should be able to understand all the elements of the world like we do. It should be able to go forward and backwards and hypothesize without about the unknown information and that sort of thing. And if that is the ambition, I think we also have to come up with evaluation metrics to see if it is coming up, if it is achieving these whatever parallels it has to in understanding the faithful world the way it is. So the evaluation metrics have to be carved out as well.
Yeah.
So I think there's a lot of research that has to go into.
I think we are at a stage where we develop a model, reach its limitations, and then evolve from there.
That's true, yeah.
I think faithful world model, as you said, seems very natural progression to what already is existing, right?
Yeah. I think that vision of it is we have to put it there and start marching towards it. Yeah. Look, what do you think? How are these machines different in the terms of learning, as compared to how we humans learn? Do you think?
So basically, machine learning is a lot based on correction based learnings, right? You give it data to learn from. It will give you it will process the data, learn from it, and give it a set of outputs. And when you see that outputs are not up to the mark, you go back to the algorithm, correct, and then change whatever is missing, and then give the data again. The process repeats itself. So it is a lot of correction based model, right? And this is natural also because machine doesn't have their own intelligence. It has the intelligence that we feed to it.
That's
Right?
true. Yeah.
So that's where the limitation of machine learning lies as well. But with humans, it's very different. What our learning model is attention-based learning model,
Yes.
right? So when we are learning something, we also know that we are learning,
That's true. Yeah.
right?
Yeah.
And that enhances our learning. So that's where we, our learning model is different.
That's right. Yeah.
If let's say we also learn the same way as machines are learning, it will take us like millennia to learn something, right? And this is happening with machine learning also,
Right.
right? It is taking like, I think we are already the algorithm, the AI, machine learning is the buzzword since past 40, 50, 60 years, right?
Yes.
And
Since Turing, maybe before.
yes, that is like what, 70 years back, right? And right now we are at a stage where machines can beat humans in chess or in a game of Go. So the computationally machines are becoming stronger in one aspect, but to become stronger in couple of aspects or in a bunch of aspects to reach to a level of AGI, I think it will take much longer.
It will. Yeah.
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 So this brings us to end of this topic. We really hope that you liked what we talked about. Whatever your views are, please drop a line in the comment. We'll be very happy to respond to those. Please like the video, share the video, help us spread the word. Thank you so much for tuning in.
Thanks, guys.